If you've ever lived in an earthquake zone, you might have noticed a strange divide. Right before the ground starts shaking, one animal is fast asleep on the couch, while another is suddenly panicking. Humans have documented this bizarre contrast for thousands of years. The earliest known record comes from Greece in 373 BC, when observers noted that rats, weasels, snakes, and centipedes abandoned their homes and headed for safety several days before a massive, destructive earthquake. We saw a highly documented version of this during the 2004 tsunami in Sri Lanka. Observers reported that local elephants sensed the danger long before the water breached the coast, fleeing inland. The humans who instinctively followed them survived. But despite centuries of these anecdotes, major geological agencies rigidly maintain that predicting earthquakes is currently impossible. To a seismologist, an animal acting weird is just a story, not data. This leaves us with a massive biological puzzle. Are we missing a vast, invisible early warning system built into nature? Or are these stories just ancient myths we tell to make sense of unpredictable disasters? The most common assumption is that household pets possess some kind of magical sixth sense that alerts them to imminent danger. The problem with this idea is a psychological trap called confirmation bias. If an earthquake hits, you will vividly remember your dog barking at the wall 5 minutes earlier. What you forget are the hundreds of other times your dog barked at the wall for absolutely no reason. Furthermore, minor earthquakes often cluster in space and time. A tiny tremor, too weak for humans to feel, might rattle a house and upset a pet. When the larger main shock hits hours later, it looks like the animal predicted the future. In reality, they were just reacting to a foreshock we missed. This is a chart showing the distribution of over 700 reported animal precursors to earthquakes. If this were just a domestic pet phenomenon, mammals would dominate entirely. Instead, mammals make up 53%, while fish account for 20%, birds 17%, and reptiles and insects 10%. This wide distribution tells us something crucial. There is no singular, mystical sixth sense. Instead, a massive variety of species are using vastly different, highly specialized physical anatomies to perceive environmental signals that humans are simply deaf to. When a tectonic fault ruptures, it doesn't just send out one type of energy. It releases primary waves, or P waves, which are incredibly fast and relatively harmless. Right behind them are secondary waves, or S waves. These are slower, but they are the ones that actually undulate the ground and destroy buildings. Because the P wave travels faster, it hits the surface first. This speed differential creates a critical window of time, sometimes seconds, sometimes minutes, where the earthquake has physically started, but the destructive shaking hasn't arrived yet. Elephants are biologically equipped to exploit this exact window. They communicate over long distances using low-frequency seismic waves. Their feet and trunks are packed with sensitive nerve endings, allowing them to hear the micro-vibrations of an arriving P wave through the dirt, long before a human feels a thing. When an elephant flees before the ground shakes, they are not predicting an event that hasn't happened. They are reacting to a physical reality that is already occurring. They just process the data faster than we do. Sensing a P wave explains a warning of a few seconds, but it does not explain the animals that evacuate a region days or weeks in advance, well before any seismic waves have been generated. To understand that, we have to look at the immense physical stress deep underground. Before a fault snaps, tectonic plates grind together under unfathomable pressure. This crushing force on the rock generates an electrical charge, a phenomenon called the piezoelectric effect. Positive ions are squeezed out of the rock, rising toward the surface. When those ions hit the surface, they interact with water, temporarily altering its chemistry. In 2009, this sudden chemical shift likely caused an entire colony of toads in Italy to abandon their breeding ponds. Just days later, a magnitude 6.3 earthquake reduced the town of L'Aquila to rubble. In China, similar electrical and thermal disruptions in the soil have caused hundreds of snakes to emerge early from deep winter hibernation, surfacing into freezing temperatures just to escape the anomaly beneath them. For birds in the air, the threat registers differently. Pigeons rely heavily on the Earth's magnetic field for navigation. When a fault under extreme stress sends a spike of electromagnetic energy into the atmosphere, it can temporarily blind their internal compasses, causing frantic behavior. The Earth broadcasts loud, physical warning signs days in advance of a rupture. The signals are there. We just lack the biological hardware required to read those specific chemical and magnetic frequencies. Now, scientists are finally attempting to bridge the gap between ancient folklore and modern data by tracking these biological reactions in real time. Through the Icarus project at the Max Planck Institute, researchers are strapping biologging chips to farm animals like cows and sheep in seismically active regions. The goal is to continuously monitor their collective movements to see if they can catch the animals reacting to tectonic stress. The system operates on a precise metric. If multiple tagged animals exhibit a synchronized spike in hyperactivity that lasts for at least 45 minutes, a central computer registers the anomaly and triggers a warning signal. A flock of birds or a herd of cattle will never replace strict structural engineering or geological monitoring. But by overlaying ancient biological instincts with modern technology, we now have a tool to feel the pulse of the Earth right before it breaks.